Hello everyone, myself Samir Raud. Today I am going to present you all the end course summative assignment of a module 5, that is applied statistics. The name of the assignment or the project is applied statistics interview grind, and the problem statement for this particular project is to write the solutions to the top 50 interview questions and explain any 5 question in this video. So let's take a look at the problem set in deeply. So the problem is that imagine you are a dedicated student aspiring to excel in job interviews. Your task is to write the solutions for any 50 interview questions out of 80 questions presented to you. Additionally, create an engaging video where you thoroughly explain the answers to any 5 of these questions. So, dear friends, let's get directly dive into the project. So, let's get started with the first question. The first question reads out that what is a vector in mathematics? So, vector is a very important and helpful feature in the field of mathematics and a data science. So in mathematics and data science, a vector is a mathematical object that has both magnitude and direction. It is often represented geometrically by a directed line segment where the length of the segment represents the magnitude and the arrowhead of a vector indicates the direction. We can perform many operations on vectors such as addition, subtraction, and multiplication by a scalar. They can be according to a specific rule of vector algebra. They are fundamental in many areas of mathematics, physics, engineering, and computer science. There are two main characteristic features of a vector. Number one, the magnitude, which is the length or the size of the vector, and second is the direction or the way the vector points in a space. So we will see in deep what is a vector. So using the representation, I am going to define you the vector. So this is a vector. The black line, this black line denotes the vector. So this is a vector u. This is a initial point of a vector. This is the terminal point of a vector. So the particular point and the distance between the initial point and the terminal point is known as the magnitude of a vector, which is particular length or a size of a vector. The distance between initial and the terminal point is magnitude, and the distance or the direction of a arrowhead of a vector is its direction. So magnitude represents in this particular way, and the direction or angle, it is represented in a theta model. So this is a vector. Now we'll look at the another question. The another question is, what is the magnitude of a vector? Before this question we have looked into the what is a vector, and now we are going to discuss about the magnitude of a vector. So the magnitude or a length or a size of a vector represents the size or a distance from the origin, that is initial point, in a given space. It is a measure of how long the vector is without considering its direction. So what it means? The regardless of its direction, the distance between the initial point and the terminal point of a particular vector is its magnitude. So let's understand with the help of particular thing. So this is a graph. Sorry for the bad and this is a particular vector. So this is a particular vector. The distance between initial point, that is 0 0, and it is particularly terminal point, we can predict it as a 3 to 4. So this is a vector. So to find this direction, we can use one particular very important and the famous theorem, that is Pythagoras theorem, to find out the length of a particular vector. So what is that? So we can see that it is a 3 in the four in the 3 in the x-axis and 4 units in the y-axis. So we can calculate that using the formula of a to find the magnitude. The square root of a 3 to the power 2 plus 4 ka square is equal to 9 plus 16, that is under root of a 25. So what will be the distance of a vector? It is 5. The magnitude is calculated in this particular way. So this is the formula to find the magnitude, and this is how we can find the magnitude of a particular vector. Now, the third question which we are going to discuss is what is the difference between square matrix and a rectangular matrix. So, first of all, matrices are rectangular arrays of a number or a variable. Matrices are used in various fields such as physics, engineering, and data science for problem solving that involves linear equation, linear transformation, and system of equations. There are several types of matrices which are important for us, that is square matrix, symmetric matrices, diagonal matrices, identity matrices, and a singular matrices. From these, we have to find the difference between the square matrix and the rectangular matrix in this particular question. So the main difference between square matrix and the rectangular matrix is that a square matrix has the same number of rows and columns. Focus on that. Thus it has a same number of rows and columns, whereas the rectangular matrix has a different number of rows and columns. What it mean? It mean that the dimension of a square matrix is n is to n, while the dimension of a rectangular matrix is m is equal to n. Sorry, m into n. Means if a 2 by 2 is a square matrix, or we can say 3 by 3 is a square matrix, while 2 by 3 or 3 by 2 is a rectangular matrix. Okay, and there are some properties to that. The properties of a square matrix is they can have a determinant, they can be invertible, they can be diagonal and symmetric or skew symmetric. And the properties of rectangular matrices, they don't have a determinant, they cannot be invertible, and they can be transposed to obtain a different rectangular matrix. Okay, so this is the basic difference between square matrix and a rectangular matrix. Now we will look at the another question, our fourth question. That will be the question number 50, the most important topic, that is what is a probability theory. So this is the most important topic in the field of statistics. So probability theory is a branch of mathematics that deals with the study of randomness, or uncertainty, or we can say that the event of likelihood. Probability theory provides a framework for understanding and quantifying the likelihood of events, making it an essential tool in many fields such as statistics, finance, and engineering, as well as we use it very much in data science field also. In probability theory, we define events as subsets of a sample space that we can denote by S, which is the set of all possible outcomes of a random experiment. We use probabilities to assign a numerical measure to the likelihood of each event occurring. Probability is always a number between 0 and 1, meaning with 0 indicating that an event is impossible and 1 indicating that event is certain, that is deterministic feature. Probability theory provides us with many useful tools for analyzing and quantifying uncertainty. Okay, so we can say that the probability is the events as subset of a sample. So sample space denoted by S. What is sample space? So for example, we have a coin to toss. So what is the probability, or the what are the all the samples we can get if we flip the coin twice? So we can either get head, or we can either get tails. So H and T are two sample space of a particular event. Okay, next, mm, there are some probability axioms. What are that? The first is non-negativity. What does it mean? The probability of an event can never be a negative. Means it will always be a positive. It can never go into the negative field. Another one is normalization. What it say? The sum of probabilities of all possible outcomes of an experiment is equal to 1. What does it mean? Similarly, we will go into the example of a coin, where we said that it will be either head or it will be either tail. So what does the normalization means? What is the probability of getting heads? That is 1 by 2. And what is the probability of getting tail? That is 1 by 2. Okay, so what will be the addition of this? So we will get 2 by 2, that is equal to 1. So what does it mean? That the sum of probabilities, all probabilities, probability of a head, probability of getting tail is equal to 1, and we have proved that. Additivity, the probability of the union of two mutually exclusive events is equal to the sum of their individual probabilities. What does it mean? It means that the probability of event A or event B is equal to probability of event A plus probability of event B. Okay, and there are some probability rules also. Number one, complement rule. The probability of an event not occurring is minus the probability of the event occurring. So what is it? That is, the probability of event A dash is equal to 1 minus probability of event A. Similarly, we have union rule, we have conditional probability rule, and multiplication rule. These are the some big rules. We can express it or describe it later. Okay, so this is all about the probability theory. Okay, now let's look at the final question of the day, and the question will be the question number 22. That is, what is the difference between discrete and continuous probability distribution? So the concepts like discrete probability distribution and continuous probability distribution are very much important and are very helpful in the field of data science and machine learning, because with the help of discrete probability distribution and continuous probability distribution, we can use these features to get and learn our model in the machine learning. So the primary difference between the discrete and continuous probability distribution lies in the very nature of the random variable they describe. What does it mean? Let's have a look. So first of all, we will discuss about the discrete probability distribution. So the nature of the random variable is that takes on countable number of values. What does it mean? So if we have a data we have a data in column, so we can count that number or the unique values of a particular data or a column. We can count it on fingers. It is not like a negative value, it cannot be an infinite value. So they are countable in nature, they are integer in nature, so we can say that they are the discrete in nature. And to assign a probability to them, to whom? To a discrete probability distribution, we can use the probability mass function. It is a mathematical tool or a formula where using which we can assign a probability distribution to a discrete probability. The example of this particular probability is number of heads in 10 coin flips, number of cars passing a toll booth, and the number of defects in a product. They all are like a full number, whole number, integer. They cannot be infinite, and they cannot be in a decimal point, and then they also cannot be a negative integer. Okay, so this is a discrete probability distribution. While the continuous probability distribution, the nature of random variable is that it takes on any value within a given interval. So this means that it can have a decimal up to a certain limit. Okay, and there is the value or the unique or the countness of this particular data can go up to infinite. Okay, and to assign a probability to this probability distribution, we use a probability density function. This is also a mathematical tool or function we use to assign a probability distribution to continuous probability. And the probability is calculated for a range of values. Get mind it, the probability for this particular continuous probability is calculated for a range of values and not for a specific points. So what does it mean that? So let's look at a representative graphical representation of a particular continuous probability distribution and discrete probability continuation distribution. So the left, the with blue line is a continuous probability distribution representation. So this is a particular curve or line we are seeing. So what does it say? It says that it is not calculated for a specific point. We are not counting here for a specific point. We are counting for a range, for a given up to certain range. Whereas in discrete probability distribution, we are counting a mass function for particular point itself. We are not like counting for a whole range or range of values. We are counting here for particular point at a given time, like point 1, point 2, point 3. We are counting and assigning a probability for each separate variable or separate data point. Okay, so and the examples of continuous probability distribution is that the height of a person, it can be a 5.4, 6.4, it can be a 3.3, whatever. It is like in a decimal. We can say that it is in a 171 centimeter, 172 centimeter, 171.1 centimeter. Okay, weight of a product, weight of a product like 2 kgs, 2.5 kgs, 3 kgs, 3.2 kgs, and so on. They are all in a particular decimal point. Okay, so in summary, we can say that discrete distribution deals with countable outcomes, as we have already seen, and like the numbers of successes in a fixed number of trials, while continuous distribution deals with the measurable quantities like time, weight, or length, and so on. So that's it with the 5 questions which I have to take in this particular video from this assignment. I hope guys you enjoyed this session, and if you have any queries, so let me know. Otherwise, we can stop here. Thank you very much.